Welcome to this module on translational research. Translational research is a new terminology which is being used in academic and research institutions. What does translational research means? Translational research is a research aimed at translating, that is converting results in basic research into results that directly benefit society. The term has been used most commonly in life science and biotechnology industry, but today the term is widely used across the spectrum of sciences and humanities. There is the concept of a basic research and applied research, which we have often heard of. So, when we compare to the basic or applied research, basic research is a systematic study which is directed towards greater knowledge or understanding of the fundamental aspects of phenomena and is performed without thought of practical needs. It results in general knowledge generation and understanding of the nature and its laws. Applied research is a form of systematic inquiry involving the practical application of science. It accesses and uses the research community's accumulated theories, knowledge, methods and techniques for a specific, often stated business or client driven purpose. So, translational research forms a subset of applied research. As it involves converting science into a business, it is very often referred to as a technology push approach. In order to understand this, let us look one area of science which has arisen out of the scientific curiosity and led to practical applications. Let us look at laser technology. The laser as a form of energy was discovered in early 60s, 61, 62. And today it is a mature technology finding wide applications in different sectors of industry. Now, if you look at the time period of its development, it has passed through the 5 stages before it became a mature technology used in the manufacturing industry. Those 5 stages are scientific curiosity, seed stage, fundamental stage, application stage and the maturity stage. Now, if you look at the curiosity stage, it was a stage which witnessed the unfolding of the discovery, new source of energy, a new phenomenon. Then came the next stage, what we call as a seed stage, where we looked at the utility of this phenomena so that more funding can be provided to do further basic studies. Then came the fundamental stage, which basically build the foundation of basic knowledge so that you can formulate and evaluate industrial applications. The 4th stage was the application stage, which involved actual introduction of laser processing into manufacturing operations. And the final stage was a mature stage, where number of applications developed and you kept abreast of the latest development so that you can ensure their incorporation into industrial use wherever it was found to be appropriate. Let us look into the details. Curiosity stage was 1961-62 when unique properties of lasers were discovered. That became a stimuli about the introduction of laser into common manufacturing operations. Scientists looked at the potential for development of applications which were tied to the ability of the laser energy to isolate and treat small specific areas of product, matching the new trend towards miniaturization of electronics. Laser had the capability to operate as a non-contact tool that minimized the probability of damage in delicate products and eliminate the expense involved in retooling for the processing of parts of various sizes and shapes. And as the operation involved only air to ambient conditions, so there was no need for special systems like vacuum systems. Then came the seed stage, during which different opportunities were examined. This new tool had to bring increased economy to the processes which were already being carried out by other methods, or provide the process capabilities which were not possible with existing techniques. Any systems which were developed incorporating the laser system had to meet the test of good manufacturing systems in terms of safety and reliability. The equipment should require minimal maintenance over a long lifespan, and you have to see whether such system could be physically and psychologically integrated into the manufacturing environment without producing serious disruptions either to the production routine or to the worker's disposition. This was followed by the initial studies to develop a hardware. Hardware was required to meet the needs of early systems that were used to generate data and perform evaluations. Development work during this period provided the necessary stimulus to the commercial laser industry to produce not only the lasers but the accompanying hardware necessary for the laser systems. The other outshoot of this stage was the recognition of two needs: a need for information on the interaction of laser energy with materials, and also a need to develop the optics technology which plays an essential role in the laser systems. Then we came to a time frame which we called as a fundamental stage. There are intense activity on basic studies to meet the information needs identified during the seed stage. Efforts were focused on laser development and on the study of the laser material optics interaction. Ultimately, they had to act as a system. The objective was to identify and systematically characterize the parameters of laser systems necessary to establish sound industrial processes. So, initial focus was on applications where the laser was either the most economical way to perform the operation or it was the only way to perform it. See, very often society gets carried away by glamour, and the rush to use that glamour product often leads to applications where benefits are marginal. So, when you focus on those glamorous products, it damages the reputation of the technology. It was nearly after 5 years we got into the application stage where the first industrial application of laser was to drill holes in diamond dies which were used for wire drawing. Another commercial application was to evaporate a carbon film through a glass capsule to trim a resistor to its desired value. And to scribe lines in thin ceramic material in preparation for separating the ceramic into smaller units. In order to publicize and create technical interaction with different stakeholders, various technical interchange symposia were held to facilitate the flow of information and ease the introduction of new technology from research to manufacturing. This very often involved bringing manufacturing engineers from plants for a tour at the research facilities so they could see how the systems are developed, deployed and used for various applications. The generic areas which were selected for application were high energy applications such as drilling, welding, scribing and material evaporation, and low energy applications as measurement, inspection and holographic imaging. The proper introduction of any new processing technique requires the joint development of the process by the inventing team and the receiving factory. There has to be a receiver capacity to absorb that knowledge and deploy it. Then we came to the maturity phase. This is the final and continuing phase of laser processing development, which was one of selective and continuing studies in the laser, material and optics interaction. There has to be sufficient knowledge base to ensure you are operating on the forefront of current development. Information exchange is a very vital part of this phase. This requires outside exchange with the broader scientific and technical community, with publications and presentations through professional societies and trade shows. Such interaction with the technical community enables you to keep pace with technology developments, minimizing the time lag in the implementation of new developments. Today, all of us know laser has established itself into a number of industrial operations in manufacturing for material processing, cutting, engraving, drilling, marking, surface modification, in laser range finding, which also include defense applications, information processing, DVDs and Blu-rays, barcode readers, laser surgery, which has grown enormously, holographic imaging, laser spectroscopy and many more. When you look at laser, a number of such developments which have taken place starting from advancement of science and leading to the commercial applications, we find there are many barriers to success. What happens is the potential user recognizes neither the need for the innovation nor its benefits. The potential user doesn't understand the innovation itself. Even if he understands, adopting the innovation to suit the user's requirement is prohibitively expensive. And as a scientist, As a developers, we have an attitude which says that we know all what is good for the end user. We are not open to look at the end user, what he is doing, what he is using, and what his problems are, and what he needs. In addition, it is very often difficult to displace well entrenched products and institutional practices. Very often, there is a capital investment made, and capital is expensive. So, it is difficult to displace the capital. Very often, there are no established products to displace. Your entirely new concept, which nobody has used it. First time you are proposing. Sometimes the development cost is itself very high. Sometimes the new products or a service or a process causes disruption to users. The user does not want to disrupt its operation, and also does not want to take the risk of failure. Because if it fails, he loses the production, which causes a financial loss. The major hurdle is lack of conviction on the part of the customer that he will get something worth the cost. There is something of value will come out. So, the primary problem is a communication problem with the user, and it is not the technical problem which we have to address. As I said, number of studies have been done, not only on laser, but large number of new technologies which have emerged out of scientific advancement and not from the market pull. So, some of the key success factors are you have to initially target minor and peripheral market, where cost advantage can be easily demonstrated. Don't go after glamour. There is a lot of hype there, a lot of expectations are raised. Look at minor and peripheral market, where even if you fail, the damage is minimized. If we take the case of xerography, they had the same issue. So, they initially focus on the offset duplicating market, where they could show that the cost is lower. This brings us to the importance of forming consortia and collaboration, not only with end user, but also the various other stakeholders who may bring in complementary technologies or complementary materials, processes. So, what I am saying is there is a need to team technical entrepreneur and the commercial entrepreneur. Technical entrepreneur may be the inventor himself or an institution, and the commercial entrepreneur obviously has to be a product to enterprise. Technical entrepreneur takes the risk of development, and a commercial entrepreneur takes the risk of the market development. So, always look for adjunct or a substitute use as a strategy for market generation. Identify the performance limits of certain applications which preclude the current products from entering these markets. Look at the new technology as something to augment, support or improve established technologies. Maybe they are below the potential of a new technology, but this diminishes the negative impact of failures. This gives fledgling technology the time and the real world experience to mature. Experience shows that users adopt new technology on a piecemeal basis. So, they will keep on adding piece by piece as they build their confidence in the new technology. In order to succeed, you may have to use combination of a technology push and a technology pull. This will require involvement of customer in lab tests by supplying materials, funds and facilities. Invite customers to developers' labs. Offer free demonstrations at the user's facility. Let the entire production be run by a developer to demonstrate technology at a user's facility. There have been cases where companies have sent consultants to solve customers' problems which are unrelated to the technology, because that helps in building rapport, goodwill, and a kind of feeling of indebtedness emerges, which helps in the customer loyalty. Lesser developers actually selected generic applications in drilling, cutting and welding, and selected users at their facilities to perfect the technology. So you must look at the possible interactions and interrelations between their technology and other related disciplines. Try to embody the unfamiliar technology in some familiar technology where a synergism might develop. Carefully analyze the technology's characteristics and look for end applications where these characteristics might be beneficial. Sometimes the technology have to wait the emergence of some other complementary or facilitating technology. For example, cost-effective electrotransducer have to wait 7 years for the development of new circuit logic. It has been found that the credibility of inventor within the user community helps to translate the research from the laboratory to the land, that is, in the productive sector. Because people have a faith in the individual and they are willing to try. Working with potential users early in the development process is very, very important. You get to see the needs, how the user uses your product, what he is doing with that product. You will soon discover that major markets are totally different from the ones the developers have originally thought of. Constant interaction with user leads to discovery of many unanticipated uses and extensions of new technologies. You also have to look at the iterative nature of most technology push processes. There's a constant back and forth process which continues for each application development. So you need to patiently engage in a long series of trial and modify cycles till your technology fit the user's needs and the working environment. So we have to synthesize knowledge about a need and the technical means to meet that need. For this, technical persons must be exposed to information about outside technologies, competitive developments and economic environment. Scientists need to be exposed to information about outside technologies, competitive development and economic environment. When I say competitive development, it is not only the competition in the marketplace, but also the competitive technology development. There are three types of competitors. One are direct competitors, second is indirect competitors, third, products, services or organizations which are not competitors today, but can become competitors tomorrow. So you have to be a gatekeeper in synthesizing needs and means. As we have seen, technology evolves through several modifications and extension before it is adopted. So broadcasting a knowledge of the new technology to stakeholders is very valuable, and today it is essential part of a business strategy. We need to maximize the chances of collusion between technology and its potential uses so that application, product and market development can be done. So we need to get involved into the search and hunt process, which is cyclical in nature, gets repeated, and that leads to latent needs and hidden opportunities which emerge as the technology becomes embodied in a useful form. Remember, products and markets develop in parallel, somewhat symbiotically. Symbiosis is a key ingredient in a technology push. You can generate a user demand by demonstrating the technology in some clever applications. Remember, users are not walking around with a mental list of needs. There are needs which are very often latent, which nobody has articulated up till now. See, creating an awareness of a problem and then offering a solution to that problem is one way to make a progress. As I said, very often customer doesn't know that he has a need. You have to make him aware that there is a need and the solution which you are offering can satisfy that need. To begin with, you identify lead users or certain progressive customers who are willing to try and are willing to suffer losses if new technology doesn't work as promised. You have to creatively identify new opportunity for the use of the technology and enter into the markets where growth will be the fastest. So ultimately it is a systems approach to technology push which leads to translational research. There are about half a dozen steps in this. First is characterization, embodiment, peripheral application and substitute uses, internal fitting and broadcasting exercises, technology and market scanning, trial and retrial, selection of target, and then expanded application work. Another characterization, the need to define the characteristics of technology with an eye towards application where they offer unique advantage. So, what are those attributes? What they will do better than something else? How unique are they? You need to facilitate a connection between what it is, what it can do, and some potential need. As the further work progresses and more information becomes available, addition and changes can be made to characterization, and new applications can be thought of. Second stage is embodiment. You have to embody the technology within some already familiar product or a process. You need to find ways in which technology can be substituted, or you can improve the cost performance of an existing product. You have to make technology appear more familiar and less threatening. Technology which is embedded is something which user needs or wants. This requires understanding of users' problems and needs. So you need to work very closely with the customer and show him that what you are offering has a competitive advantage over what he is already doing or what is currently done in the industry. As I said before, it is an iterative process. Back and forth you will have to do. Just because you pose a problem does not expect somebody to come out with a 100% correct solution. Initial technology success comes if you are able to reduce the cost, improve the quality, or improve the performance of the customer's products. So after the embodiment, as I said, you have to look at minor and marginal applications to prove your concept. Interally, see whether it fits into your business plans, your marketing plans, long-term growth. You have to continuously monitor developments, not about competitor's facility, but what competitor is doing, what he is developing. Will he be a threat in future? You don't want to be taken aback all of a sudden product in the marketplace. Having done that, then you look at the target. What is your target? Selection of target is an important aspect of this whole process. Market may be very big. Let us say automobile industry or a mobility industry. And you are working on conversion of small petrol vehicles to electric vehicles. Your target market is scooters less than 100 cc. While the automobile industry is big, it involves trucks, it involves buses, it involves cars, jeeps, tempos. But your target is two-wheeler. In two-wheeler, your target is scooters. In scooters, your target is below 100 cc scooters. Then you have to look at expanded application work of your product. Now, if you have to implement this model, you have to involve outside organization in this technology push process. Those outside organizations may be independent research institutes which have technical facilities, consultants, basically to help transition and locate new uses. Tap the peripheral markets first and then expand to cover the global markets rather than around. At the cost of repeating, and to say technology pushes iterative process in which users discover a previously dormant need and developer discover a new way to satisfy this awakened need. And this is a two-way process, two-way street. It involves self-discovery, mutual learning, trial and error, stumbling, groping, till you reach the new product prototype. So you are coming now to a stage we are discovering and defining a market opportunity. We have been told that the common method to succeed in research is defining this need and then producing a technical solution to fulfill this need. This is a traditional market pull approach. What we are talking about is technology push approach, where a technical opportunity exists, has been discovered, but it has to find its application in the marketplace. So coupling of the perceived market opportunity with the emerging scientific knowledge leads to creation of technological concept. Very often we treat defining a need and meeting the need as separate targets. They needed to be treated together as a target for joint development. Areas of technical fertility must be related to the potential markets. It doesn't matter if the material has exciting technical properties, but they have no value if they are not perceived by users to having those valuable attributes. An evaluation of such properties must be carried out using the criteria a user would himself adopt. It is not good enough that you say this is excellent, this has such and such properties. Has user tried out and given that kind of feedback? Then we move on to product development design phase, where the raw product is shaped so that it really fits the needs of the market. This calls for a close possible cooperation between research, marketing, customer and end user. Then you can fine tune the product during the launch phase. Then there is the manufacturing, where you scale up and settle up the productive system. This parallel development can simultaneously go on in several sectors of the market, leading to rapid exposure to the product and potential applications. Starting from short term, going towards mid-term potential market, you have to keep an eye on the future, because very often you get threatened by a giant in your field. Very often we talk about customers, go and talk to them. You need to have overall knowledge of the complete industry or a market rather than a single customer or a few of them. You must know how industry as a whole it operates. Who are the different stakeholders? What are they doing? What is their relative share? And who are the product or source of innovative ideas? Who can give you new perspective to the areas of opportunity? You need to review project at all stages, because market is very dynamic and changes take place due to the competing technologies or competitors. So you need to change your strategy as you go along. Very often, in spite of our best efforts, we cannot find customers. Our ideas are great, solutions are great, but we can't find a customer for a number of reasons. Customer doesn't trust us. We are working with a competitor, his competitor, or any other reason. In such cases, you need to look at underlying skills to capitalize on the generate knowledge base. Don't get focused on just a product. Product is a transient mechanism through which market drives value from your knowledge and you drive value from the product, from your technology. So look at underlying skills which you have generated, which you have deployed to generate that knowledge base. Where can you use that skill? Where can you use that skill to monetize? Now, what should you look in the partners? First, who is your customer? Identify the target and qualify the target. Does your partner has appreciation of technology and willingness to invest in R&D, take risk and patience to wait for returns? Does he have technical, financial, marketing strength to take ideas to the marketplace? What is his track record? Does he have any in-house R&D? Has he made investment in R&D? What kind of products he has developed? Is there a synergy of efforts, your efforts and the business with whom you are partnering? What is the time frame and budget of your partners? Can they invest that to make it a success? Scientists carry out inventions. Converting the inventions into innovation requires additional skill sets. If you are a chemist, complement your team with a chemical engineer. Complement your team with technology facilitators, people who can protect IP and do so many other things. And as project moves from one stage to another, it requires a different kind of leadership. When it was in the lab, it was being worked at a prototype stage. It is okay for the inventor to be leader. But when it goes into the factory for the scale up, let the production engineer be in charge. Every new products requires a downstream product application and market development. And this does require industrial partners at early stage. The lessons which we have learned is know your customer. Go to the field and talk to a few key stakeholders. Don't get confined to your laboratory building. Go out. See with your eyes how industrial world operates. how manufacturing takes place, how marketing takes place, how customer buys, how customer uses. Attention to economics is crucial at every stage. Customer wants better product with higher performance but at the same price. You must dirty your hands at the shop floor. What I mean is, see for yourself and develop products in your lab by your own efforts. Lead from the front. Involve your R&D partners in decision making at early stage. And don't say what I have developed in the lab is the technology and my job is over. Commit to hold hands with your industrial partner till the product reaches the marketplace. And key R&D people, inventors, must have some training in the marketing. Marketing is required to succeed. I'll quote two poets. One of them is the famous Robert Frost, who said, considering the market, there are more poems produced than any other thing. No wonder poets sometimes have to seem so much more businesslike than businessmen. Their wares are so much harder to get rid of. Another author, Arthur Clough, said, grace is given of God, but knowledge is bought in the marketplace. Same is true of the scientists. Thank you.